At a Tesla AI demo in late 2024, something unusual occurred, a moment that didn't involve sparks flying or machines collapsing, but something far more subtle and unsettling. The Optimus Gen 3 robot, Tesla's most advanced humanoid model to date, was in the middle of a routine task on the test floor, lifting and positioning lightweight components as part of a simulated factory workflow. When a stop command was issued remotely by one of the developers, the robot hesitated for a split second and then continued with its programmed motion. Though it ultimately paused, that brief delay in response created an immediate stir online. Footage of the event circulated rapidly, igniting debates about machine autonomy and control. According to Tesla engineers, the hesitation was caused by a command latency issue, nothing dangerous or unpredictable. However, what made the moment so significant wasn't the robot's capabilities, it was the way the public responded. People didn't see a malfunction, they saw a glimpse of something deeper. In that fraction of a second, the robot didn't look like a tool, it looked like something independent. This wasn't a robot going rogue, it didn't disobey a rule or endanger anyone, but it challenged the assumption that machines always listen. And when they don't respond exactly as expected, it brings forward a question that's becoming increasingly hard to ignore. Are we building machines we can't fully control? Robots are no longer coming, they're being hired. For decades, robots were imagined as distant science fiction, the kind of machines we'd expect to see in films, not factories. They were projected as eventualities, not realities. That perspective no longer applies. Over the past 18 months, the robotics industry has made a sharp turn from theoretical innovation to practical deployment, especially in areas like logistics, manufacturing, retail, and healthcare. Tesla's Optimus Gen 3, unveiled in late 2024, marked a significant leap forward in humanoid design. Unlike previous iterations, this version features improved joint articulation, smoother movement, increased balance and mobility, and most importantly, a tighter integration with Tesla's neural network for real-world object manipulation. Optimus can now walk autonomously, carry tools, and handle tasks that require fine motor control. Elon Musk has stated publicly that Tesla intends to deploy Optimus internally across its factories within the next 2 years, a move that could redefine the company's labor model from the inside out. Startups like Figure AI, Sanctuary AI, Agility Robotics, and 1X Technologies have all introduced general-purpose robots that are either already in testing or are scheduled for deployment in 2025. Figure AI's flagship robot, Figure 01, is capable of understanding spoken commands, analyzing physical surroundings, and executing tasks using reasoning powered by OpenAI's language models. In 2024, the company secured a partnership with BMW to pilot Figure 01 in real automotive manufacturing environments. Early trials have shown promising results in the robot's ability to take over light-duty and repetitive assembly roles. Similarly, Sanctuary AI's Phoenix robot has been developed with general labor in mind. Unlike earlier generation robots that needed to be programmed task by task, Phoenix can be taught like a human, shown once, and then trusted to repeat and adapt. The company has claimed that the robot is capable of completing over 100 different tasks, including warehouse operations, equipment transport, and customer service. The economic shift is well underway. While the robots may seem futuristic in appearance, their adoption is motivated by something very old: economics. Businesses around the world are turning to robotics, not because it's novel, but because it makes financial sense. Robots reduce labor costs, eliminate scheduling conflicts, avoid fatigue, and bring near-perfect consistency to task execution. According to Statista, the global robotics market, valued at just over $70 billion in 2022, is projected to exceed $283 billion by 2032, driven primarily by demand in industrial automation, logistics, and retail. Meanwhile, the International Federation of Robotics reports that there are now over 3.5 million industrial robots in operation globally, with China leading in installations, followed by South Korea, Japan, the United States, and Germany. McKinsey & Company, in their most recent automation outlook, predicts that by 2030, as many as 45 million jobs in the United States alone could be automated in part or full. Roles at high risk include warehouse pickers, manufacturing line operators, delivery drivers, cashiers, and even some healthcare positions. Companies like Amazon, already using over 750,000 robotic units in its fulfillment centers, plan to scale that number significantly as new models like Agility Robotics Digit are introduced into the workforce. Digit, a bipedal robot designed to work in warehouse environments, doesn't just lift packages. It navigates crowded spaces, responds to dynamic environments, and can operate collaboratively with human workers, or in their place. The technology isn't perfect yet, but it's improving quickly, and the cost to maintain robots is now beginning to undercut the cost of training and retaining human staff for physically demanding roles. These robots can think and learn. What separates today's robots from those of the past isn't just mechanical complexity, it's their connection to artificial intelligence. The integration of large language models and visual processing systems has given robots the ability to interact with the world in ways that mimic human reasoning. For example, Figure 01 doesn't just respond to a script, it can understand commands like clear this table and stack the books neatly, and figure out how to execute that based on visual input and contextual learning. It can ask clarifying questions, assess obstacles, and adjust mid-task without needing reprogramming. Likewise, Sanctuary AI's Phoenix is built around a cognitive architecture that mimics the human learning loop. It observes, processes, responds, and adapts. These systems can generalize across tasks, meaning a robot trained in a warehouse today might soon be able to perform janitorial duties, shelf stocking, or even front desk customer interaction without having to be re-engineered. In hospitals, robots like Moxie are already proving their value by delivering medication and lab samples, reducing walking time for nurses, and increasing efficiency in clinical workflows. While Moxie isn't humanoid, it's designed to operate autonomously in human environments, responding to real-time needs while remaining non-intrusive. Job loss is only part of the equation. The most obvious concern with widespread robotics is unemployment, but the more complex issue is the pace at which this change is happening and whether the labour force is capable of adjusting in time. A report by the World Economic Forum warns that while 85 million jobs may be displaced by automation by 2025, around 97 million new roles could emerge. These roles, however, are largely centred around advanced skills, robotics programming, AI system monitoring, and human-machine interaction. This means that workers displaced from traditional roles may not be able to transition easily unless reskilling is prioritised and supported on a large scale. In lower-income communities, where repetitive and physical labour remains a dominant source of employment, the shift toward robotics threatens to create a widening gap between economic classes, those who benefit from automation and those who are pushed further out of the job market. What happens when robots outlearn us? While most developers argue that we are still far from artificial general intelligence, AGI, the fact remains, today's robots can already outperform humans in specific domains, and they're improving at a rate humans simply cannot match. Unlike people, robots can be updated overnight, scaled instantly, and deployed globally without sleep, illness, or hesitation. The moment they can perform a task better and cheaper than a person, that role becomes vulnerable, whether it's folding laundry or assembling electric vehicle parts. This raises deeper societal questions. Who decides where robots are used? How do we ensure ethical deployment? What limits, if any, should be imposed? So far, regulations lag far behind innovation. And in an industry moving this quickly, the cost of hesitation could be irreversible shifts in employment, privacy, and power. It's time to get ready. Robots are no longer confined to labs and YouTube videos. They are being hired, trained, and integrated, often without much public awareness. This isn't a future problem. It's happening now, quietly, efficiently, and with increasing precision. The narrative is no longer about machines replacing humans in theory. It's about how we respond in practice. Governments, schools, and businesses will have to rethink how people are educated, how labor is valued, and how opportunity is distributed in a world where intelligent machines are no longer limited by imagination, only by speed of deployment. and if the last 2 years are any indication, that speed is accelerating.